first half is actually introduction to big data. And in the introduction to big data, we will talk I will talk about the big data introduction and then extract transform load concept and little bit of Hadoop history. And we will continue the Hadoop after next week lectures. So how many of you are aware of big data, or you think you are working on a big data? Or no idea about what is a big data? So you all know big data? Should I at least one can give a response? Now the question is that what is a big data? We hear in this lecture, in the previous also, lots of data and lots of computation. So the question arises, what is so much noise about big data? The thing is that before the Web 2.0, the social media invasion on our modern time, the amount of data we were producing was not too much. In fact, if you think how much data we are generating, so as per an estimate, every 2 years, we are generating 90% of the data what was there earlier. So like in 2021, now, whatever is the size of the data of the world, so currently the size of the data of the world, which was estimated in 2020 was around 60 gigabytes. So we have a kilobyte, megabyte, then we have gigabyte, then terabyte, and petabyte, and we go further, then we get a zettabyte. So the world total data in 2020 was estimated to be 60 gigabyte, but by 2022, 90% of new data will come, and that will be roughly around 114 zettabyte. So the amount of data is actually growing and growing and growing, and that's the thing about big data. But does the big data means what? Means how big is the data can be termed as a big data. Any idea? Is 10 megabyte is a big data, or it's 1 terabyte is a big data, or 1 petabyte is a big data? So just to give you an estimate, Uber, which is a car hailing service in the US and in some other country, it generates around 100 terabytes of data every day. Whatever logs and everything it is doing, it is generating every day 100 terabytes. That means in a month, it is 3000 terabyte. So roughly 3 petabytes. Now, that is a big data. Can 100 megabyte be a big data? Any response? Okay. So we will see today that when someone asks you that someone is working in big data, then the questions, there are certain criteria on which we can define if it is a big data or not. Yes, the volume is not the only reason to define it as a big data. So depending, the key point is that depending on the domain and depending on the computation platform and the business, data can be a big data for that particular business. It may be 100 megabyte, but it can be a big data. So before this big data invasion came, or social media invention came. We are currently familiar with the relational database system, which is to understand is in a row and column format. Like if you don't know RDBMS, then for you, then consider a table. Like in a table, the data is stored in a table format where row and column will have the data, right? So that is an RDBMS system. So earlier, we were happy with RDBMS system for 30, 40 years. The RDBMS system was okay. I mean, until 2002, 2003, we have not much issue with RDBMS. Bank practically use RDBMS. Still, RDBMS databases are more commonly used. Like around 50% of the databases in the world is still holding in relational database RDBMS, more than 50%. But then there are other databases out there. So in RDBMS, bank keeps the transaction. RDBMS data has certain property, which is called as ACID property, ACID. And that property actually enable the any organization to actually verify a particular transaction has been happened or not happened. Let's say if we are going to buy something on an e-commerce platform. So e-commerce platform is going to show something in the cart, and that cart will have certain money, and then we will go for checkout and then go for enter the payment detail, and then the e-commerce platform, we say the payment, then the payment, it will say, okay, transaction is done. Sometime it also asks to connect to our bank sometime. Now, when they say that transaction is done, in the e-commerce kind of platform, it is very hard to say whether transaction has already actually been done unless we go and check in our bank. But if the background is RDBMS, then in a RDBMS system, if transaction has been committed, it is quickly verifiable and authenticated. Now, bank used to are relying on it. Even now, all the bank transactions, especially the financial transactions, are still in relational database like Oracle or MySQL. Now, bank generates lots of data. Right? For example, there are, if we are doing, let's say, Spara Bank, right? Couple of you have account in Spara Bank. Now, Spara Bank has the banking transaction where we do the transaction, we whips our friend, or we transfer money, or we pay to different point of sale system, POS system. And there, that is going to the bank. But then the bank also is collecting the data from their social media. When we are making a call to a bank, then they are actually logging the calls. Now chatbots are there. When we are interacting with going to the bank website, then the chatbots are interacting with us. That is also getting stored. And the bank also had social media account like Facebook or maybe Instagram or maybe Twitter. So they are getting lots of data, which are not RDBMS type or row and column format. They are of different format, like log data can be in text format, social media data can be in a JSON format. So RDBMS is meant for structured and tabular data, right? Now, the structured and tabular data doesn't store there are image, video kind of data, like bank is generating other type of data, which can be a flat file, which can be a JSON file, which can be image, audio, video. In row and column format data also, we can store, like you have seen a blob and all, which can handle the unstructured data. Means any kind of data we can put in the blob, right? you have done the colloquium on it. But can we do the processing of it? Means really a fast processing is going to be a Herculean task. So to sort this, the NoSQL kind of data has came up. Now this, like for example, Facebook, right? If you go and when you open your Facebook account, you see all your friends' things are getting populated, whatever updates are there coming up. Or if you are clicking to your friend's profile, then everything related to that friend's profile, like what the person has commented, what image shared, what video shared, what like, what dislike, all you can see. Now, all this information is not, means Facebook cannot show it if the data is in a structured format, because then it is going to, how it is going to quickly display the data, because when it is a structured data, the going and finding a particular information in a very large data is going to be taking a long time. So there are other databases, and those databases came up with the invasion of Web 2.0, 2002, 2003. Now, the Web 2.0 has created tons of data. Now, in this regard, like RDBMS data were doing the job and still doing the job pretty well, then there are other kind of requirement in modern businesses have. For that, NoSQL type of databases are there. We will study about what are the different types of NoSQL database one of next week. But as I was asking you, what is qualified as a big data, right? Now, to qualify as a big data, one has to think like, if someone say, what is a big data? I ask you, that is the 10 terabyte or 1 petabyte is a big data. For a company like Facebook, 1 petabyte is a big data, right? And that is called volume, amount of data. But let's say if we are working, if we have a wearable device, for example, let's say this wearable band, and this wearable band has a small camera, and this wearable band has, let's say, 2 GB of memory space. Now, for this small band, which is actually running on ARM chip, which has a few megahertz computation capability, and the storage space is about 2 GB. For that, 1 petabyte is not a big data. For it, even the 1 gigabyte is a big data. For a laptop, which has 8 GB of RAM, and if we have a data, let's say an image or a video of 4 gigabyte, and if you want to do any computation on that 4 gigabyte for a laptop of 8 gigabyte, and at any point of time, that 4 gigabyte of video can be a big data for a laptop which has a small computation power as well as small RAM capacity to do a processing. Processing means, let's say if we do some kind of matrix manipulation on this 4 gigabyte data with full data into the picture, then minimum amount of RAM will be 12 gigabyte of RAM, and my laptop has 8 gigabyte of RAM. So in that case, even 4 gigabyte of video data can be a big data. 100 megabyte can be a big data for something which has a small computational capability, like Internet of Things kind of devices. Sensors are there in our smart homes. For those sensors, the 2 gigabyte or 1 gigabyte or even 100 megabyte can be a big data. So there are 3 V's of the data which actually acceptable as a big data. One is a volume. So if a particular data doesn't have to qualify everything, like it does not have to qualify volume, velocity, and variety to call it a big data. One of the topic, one of the criteria, if it satisfies, then it can be a big data. Then comes the velocity. Right now, what is the velocity of the data in present time? You think I was talking about the Alibaba single day sale, or we also know Amazon's Black Friday sale. So Alibaba on a single day last year, they sold for 74 billion US dollar goods and product, right? How they are managing it. So velocity is very important for them. The $74 billion of product they are selling it, they are using a real-time analysis, sentiment analysis of the people, what they are searching on their website. So before the big day sale, what they do, they don't know what user is going to buy. So what they do, they know that user is going to buy mobile phone, and then they release a marketing strategy. Okay, today from 10 o'clock to 12 o'clock, if you buy mobile phone, 40% discount is there. They will not say which mobile phone. They will say 40% discount. And then that time, if user comes and they search something and they buy mobile phone, then they get a initial pointer like this kind of phones people are interested. Then they plan for the big day sale, like what they will start as a token. So in the few days before, or a week or 2 weeks before, they actually get a token of the initial information. And on the big day sale, when the clock ticks midnight, or let's say 8 o'clock in the morning, when it starts, then it look after, let's say they want the Apple new product has come, Apple something X, right? Apple 14 or Apple 15. So let's say Apple 14 has come, and the Amazon or Alibaba thinks like people are interested to buy Apple 14, so they plan. But during the transaction time, when the big day sale is going on, that time the user is searching mobile phone which are of Samsung, or maybe Oppo, or maybe Xiaomi. And if they see that more and more users are actually going for Xiaomi kind of phone, then they start reducing the price of Xiaomi phone, and they start giving promotional information. Okay, buy this item and you get this, and buy that item and you get this. So this is where they actually in real time, they understand or analyze the sentiment of the user. And that's where the velocity comes. Then another example of velocity, I hope some of you has watched this Squid Game. And Squid Game is become a viral. I see in Netflix, it is trending in the top all the time. How the Netflix is doing it means, so let's say they first bring up with the promo, and they start, people start reviewing or commenting on YouTube or on their social media platform. And from there, they analyze, okay, what is the sentiment of the people who are going to watch it. And when they release on the day, and then during the release, they, let's say on actual release, the reviews in IMDb, let's say 1. So if a review is 1, then the Netflix cannot do anything, or review 1 or 2. But if the review is 4 or 5, then the Netflix can actually do the promotional activity and can boost the viewership of those the movies or TV series. As you can see now, Squid Game's promotion is going on and on, because it is becoming like a viral, and it has become this year's biggest TV series of this year. So this is what require a velocity. That then another example, like if you go and do a shopping from a credit card in India or in China or in Singapore, then if we do a large transaction, then immediately what do we get? We get a SMS, okay, there is a money has been charged. But then I went to a shop, let's say called Tiffany, and I bought a diamond ring for 5,000 or 10,000 Other than the SMS, I am going to get promotional messages that from the Tiffany saying that, and that is in collaboration with the bank. Immediately I will going to get a call or more information, like if you buy more now in 1 hour, you are going to get 20% discount or 30% more discount or a 50% discount. So that require the computation of all this to happen within few seconds. And that is the velocity. Otherwise, if it doesn't happen in few seconds or minute, then I have left the shop. And the moment I left the shop, it is difficult, the person is going to come back and buy the product. So there comes the velocity, speed of the data in and out. And velocity can be of any scale. For a big day sale, a velocity can be 15 minutes. Using AI, machine learning, or many kind of method, the automatically system is deciding what promotional to do, 10%, 15%, what kind of and what kind of user they should be throwing the promotion. Then comes the variety. As I said, the nowadays data is not only the relational database where data is in a row column format. We have tons of unstructured data like image, audio, video, comments, the blogs. So varieties of data are there. And if these are the 3 V's of the data, thus the world has stopped only with the 3 V. No, the world has not stopped only with the 3 V. Some are saying there are 5 V's are there. Some are saying there are 7 V's are there. But for our course, for our exam purpose, if I ask what are the different V's are there to be classified as a big data, then volume, velocity, and variety. There are, if you go by the 5 V, then 3 V will be there, and then comes the value. Value means what value the data is creating, or can a value be generated from a data. Like let's say a company is storing Uber, let's say Uber. They are getting 100 terabytes of data every day, right? If they're getting 100 terabytes of data every day, if they don't do anything with the data, then that data storage is not a problem. We can store on a cloud. 100 terabytes every day can be stored. But if there is no value has been generated, then it is just they're putting into the storage, and if not adding any financial or any business improvement for Uber, then that storing the data has no value. But if it is helping the Uber to really do the better job in their business, then it is adding the value. So comes the value. Then come the veracity. That means quality of the data. We can put sensors at many places, or Uber can start getting the data of all sorts of whatever Uber car is there. Then they will put the cameras everywhere in the Uber car, and it is generating the data. But if those data has no quality by which a value or a business improvement can be possible, then that doesn't qualify as a veracity. But if it is a quality data, even a small data can be helpful to be classified as a big data. Then comes the variability and the visualization. So big data world in general, there are 3 V's are there: volume, velocity, and variety. I hope this point is clear to you. If you have any question on it. Any questions so far? Should I proceed? Yes, for exam, it is only 3 V. This weekend, I will be preparing the exam paper. So as I have already asked you, what size of the data can be termed as a big data. So you know already the answer, that anything can be big data depending on the system which will process the data. So the question is, what is the difference between variety and variability of the data? Variety means we have a data of various types. Now variability means if we are getting we have put a sensor, let's say a camera, and if it is looking only to the water, just this water, and data is just getting a static, or the camera is only put into the wall and that wall has no activity going on whatsoever, then just storing that data is not going to be of any meaning. So we need a variation in the data, in whatever data we are actually collecting. So that is the difference between a variety and variability. Is that clear? So I was saying the RDBMS what RDBMS can do, let's say. RDBMS we can consider can be from, it is a table, can be from kilobyte to terabyte, right? Now, there are many kind of RDBMS systems are there, like Oracle, MySQL, SQL Server. If the data going bigger, let's say 1 terabyte or 2 terabyte, and the server doesn't have a space, then we can store the data in many servers. That's fine, no problem. Like Uber is generating if 80, 100 terabytes of data, then it can be stored into different places, right? Now with the increase of the data, and in order to avoid the duplicity, what is done in the technical world is a normalization. That we normalize the data so we don't store the duplicity of the data. So when you will study, some of you have studied already the database system, and some of you will study the database system in next year or next semester, then you will understand what I am talking about, this normalization. But just for this lecture, I'm not going to ask you normalization or duplicity. So in the RDBMS world, when the data started increasing, then people find out a solution that in order to store everything, which will be trying to avoid the duplicity of the data, and we normalize the data. So now data is normalized and normalized into different table format, right? Now, if a bank or let's say Amazon wants to find out iPhone sale in US, how much iPhone users are there, or how much iPhone is getting sold in US, how much iPhone is getting sold in Norway, or how much iPhone is getting sold in Germany or in Bhutan. Now, when Amazon will store this information, now US, lots of people are using iPhone or buying iPhone. In Norway, also people are buying iPhone, Germany. So country specific, Amazon wants to know that, okay, search query where all the iPhone was sold. So now we have stored the data into different table. For US, a different table is there because we don't want duplicity. Then Norway, then Germany, and Bhutan, right? Bhutan has a population of around 400,000, 500,000. Now, the table for Bhutan may be of kilobyte size. But if the table of US can be of gigabyte or terabyte. Now, for kilobyte table, the search and query will be fast, and query is done, and then it is going to wait for other table to get queried, which is of larger size, and larger the size of the table, it is going to take much more time. There are many ways to actually do the query faster, but still in the relational database, it is going to take time. Then what we do, we try to solve this problem. We join it. We have to do the join operation if we want to do the query of all this. And this join operation actually going to take time. So what to do if RDBMS table size increases? So when the RDBMS table size increases, the logical partitioning of the data is done. So scientists came up, engineers came up with a solution that we will partition the data logically, right? So one data will be stored in one place, other will be here, this will be here. So this way logical partitioning is done and we can do the processing better. But even with the logical partitioning, the query is slow with the increase in size. And then we have a requirement in the modern time to processing of the unstructured data. And that was not getting possible with RDBMS kind of system. We can keep the data in RDBMS, like we can store image and video in a row table format, row column format, but then we will not be able to process it. And then cost of this RDBMS system are also very expensive. The servers and all are very expensive, and this different kind of software or a platform like Oracle, SQL, all these are expensive. What to do? NoSQL database came, which actually helped in solving quite a many problems which RDBMS had. Now, assume what people were doing before this NoSQL came. Assume before Web 2.0, what was happening traditionally? Like there are customer relationship management data. Customer data are there, their name and their location, their account, and all the informations are there. So a company is storing that. Then their transactional data they are storing in Oracle. Then they have the internet data which they are getting from their website or they getting from their other places, and those internet data are in XML format, and that is also a data for company. And the internet came before the Web 2.0 requirement, so internet was there, so that was also generating XML, and they were storing it in XML. The XML, then there is a social media data. The Twitter gives the data in JSON format. The Facebook gives the data in a graph format. So internet data, social media data are also there, that also companies are storing. Then there are customer care log files, as I was saying, when we make a call to a voice over IP system or we talk to the some customer care representative, and those they may do the logging, and that is also keeping the log file. So those are the flat file. There are third parties which are actually working with the company. They are providing some data, and that also getting maybe stored as a flat file or an XML file. And then there are others data are there that is also companies are keeping it. So when this kind of increase in data happened in back in 90s, then the data warehousing came. And so what they are doing it, if you simply store the data, it is not going to help it. And then this extract, transform, load kind of technology came up, in which what happened, it extract the data is at a particular time point, and it is going to transform to be in a processable format, and it is going to load to the central server. And that is going to go to the data warehousing. And at the end of the day, there is a business intelligence tool like Tableau, etc. are there that is going to process the data. Still, we are keeping the data, we are extracting it. Extraction is taking time. There are many companies emerge only to handle ETL. There are many company products are there only to do data warehousing in time, like 1998, 2004, 5 data warehousing was popular. Lots of engineers was needed who know data warehousing, who know how to do better data warehousing. Now, all this actually still had a limitation, right? Because it only does, it is not a real time. It is going to be done at certain, after certain duration, which do have the data, and then This was actually the traditional enterprise solution. Like if you put something into the system, any kind of change, they will say, okay, at the midnight, the server is going to run, and then you will see the changes next day. So anything will happen next day. And that's what a traditional enterprise solution was there. And the world was happy with this until 2002, 2003, 2004. But with the invasion of Web 2.0, so much data is getting generated, the world is in need more solution. The previous solution had a limitation. It was not a real time. It was costly, and scalability was really a trouble. It was not scalable. And if you talk to the storage people, they say, no problem. Okay, store the data. If we need more data, get more server. And whatever the storage problems are there, then make it a network attached storage, or make it a storage area network, SAN type of thing. But this is also not helping, right? We want something to be really fast and something real time, which can actually help the company to solve this problem. And that's how this Hadoop came. NAS and SAN doesn't solve the problem of the businesses. They needed something which company can do this real-time operation. The ETL kind of system or data warehousing kind of system were not really helping company to move faster. So Hadoop came. Hadoop was being developed in collaboration with Google, Yahoo, and other company. In 2005, the Hadoop paper came up from the Google. And then other companies started coming in like Cloudera, Hortonworks, MapR. These are all provide the Hadoop solution. We will study about Hadoop in next lecture. Then this you have seen this HD Insight in the Azure. Then Big Insight is there. All this started coming to handle the NoSQL or unstructured data kind of environment, or also providing the solution, the scalability. Earlier kind of system, all this NAS and those hardwares or servers are used to be very expensive. But Hadoop systems, you can really use the simple off-the-shelf computers, which is even older, and you can cluster a lot of old system to make a Hadoop cluster, which are not expensive. You don't have to buy a really expensive modern time system. So 2003, the Google file system paper came up from Google, and 2005, this Hadoop, Duke Cutting and Michael Cafrela, they developed Hadoop. And 2004, MapReduce came. We will also study about MapReduce in next few lecture. Then to handle this NoSQL kind of database, Apache came up with its own database system, which is called HBase. And 2006, Yahoo gave the project to Apache. Means it was HBase was from Yahoo, but then Yahoo said, okay, Apache, I want to make this HBase free. So then this Apache has taken this HBase, and now it is going integrated and been used by the industry very much. 2008, there was used to be sorting challenges, like terabyte of data is given, how quickly a particular solution can sort it. So Hadoop platform actually won in 2008 to sort 1 terabyte of data, and it took only 297 seconds. Sorry, it took only earlier system was taking 297 seconds. It sorted in 209 seconds. So it came into the focus of the people. Later on, other things required to work on Hadoop like Avro, Chukwa came. Then Hadoop, HBase, Hive, Pig. Hive and Pig we will see in the next lecture. What is Zookeeper, we will also look into then next time. Then the lots of new kind of NoSQL database came like Cassandra DB, MongoDB, DynamoDB. All these we are going to study, see in a briefly next lecture. So with this, I will stop for a while. Let's say we meet after 10 minutes